Hello guys, and welcome to our next video about Python internals. So far so good. We have covered the built-in types, we have made a change to the source code, recompiled our Python, and learned a lot. But in order to go further and to get extra deep knowledge, we need to understand the compiler part of the Python language. In other words, we need to understand how actually the Python acts when we run our code file. To get the idea, let's start with the very basics. So when you run, we have this dummy.py file, which is quite simple. So we have a list, we have a function. It's returning the doubled values of inside the list with list comprehension, and we just call this function inside the print in order to get the printed list. So it should be 1, 4, and 6 at the end. So first part of the so-called compiling our code is lexical analysis. In other words, it's a tokenization. It's called the tokenization. So this is basically when Python reads a source code, it first converts it to a stream of tokens. The stream of tokens, which is a word like units of the language. So what I mean is just when you apply this module tokenize to our dummy.py, it will tokenize all the existing code lines, and whenever something you typed here, it will be tokenized. So it's a word like units of the language itself. So our files encoding is UTF-8. So we have name operator like equal here. Then we see that we are opening the a list here and applying numbers and operator like a comma here. We have new line, and we have name def. The unique, the reserved unique tokens for the Python language is like indentation and dedentation. So when you create a function, as you remember, that you have 4 space and 1 tab, it's called indent, and it's also a predefined token for the Python language. That's it. So it's first tokenized, then it's going to parser in order parser to create a so-called abstract syntax tree, or AST. It's actually how to say what will happen in our program. So basically, let's just use it. So open up the interpreter. Then we are going to import AST. Let's just clean a bit here. Import AST, and we are going to open our file. RB. So as if, what happened? Oops. Yeah. As if, and we are going to create the tree with AST parse this f read. Great. And we have such AST pretty module which you need to install, and we are going to use it to print the tree itself and show offset false. So we have tokenized it. Then we are going to create the abstract syntax tree from our code. What's it? So there is a body, and it has the target is a name. It's assign actions, and there's a k name which is a list with value 1, 2, 3. There's another action here like function definition, which is given that we have no arguments, so we have no position only arguments, we have no keyword arguments and other things. Inside the function, it's returning the list comprehension, and that's it. Then we have expression which is a function call, and function call is a print. So that's basically the AST, and it shows what actually your code are going to do. I've omitted some parts for simplicity, and I'm going to directly to compile our code to the bytecode here. So another so in order to run actually our code, we need to compile it. So we are going to assign to the code variable the compile. So we are going to compile this tree with file name dummy.py and with exec mode. That's great. So if we exec the code, it's actually executed. So what we did so far, so we have created the abstract syntax tree, then we compile this tree to the code object, and it's created the code object, and we executed this code object. So as you see, inside the code, it's actually executed this function and printed for us. So how to get the extra info from our code object? So there's a module import this, which is for disassembling. So let's print some information for our code, actual compiled code object. So this code info will give you some bunch of information here. So we have module name, and actually we have a code object, and this code object is the compiled compiled version of the function. So each function has its own code object here inside the function. I'm picking like less terminology and plain English to explain the things. It's not important to exactly understand what's going on behind. Just feel the thing that there's a code object, there's abstract syntax tree, it's compiled to the code object, and code object stores some kind of information inside it. So we can get some extra information from our code object. So it has the many things, but the important part for us here is this CO code. This is actually the I would say the bytecodes or opcodes, operational codes, which our interpreters take a steps to run our code. We will dig into the opcodes and the evaluation loop in the next video, but I'm just going to run some code here in order to get the idea here for you, in order to share the idea here. So if we just run in this code, CO code, it will return some numbers. So this is the numbers, predefined numbers of the operation codes. So this code object will show the exact step-by-step actions our interpreter is going to do in order to run and finish our code. So it starts from build list, maybe. Yes, build list, which should be this 103 of its operational code, and then it's loads the constant using the load const opcode, I'd say, and stores the names. Then it's going to use this code object and assign this code object to the myfunc name. It will store this name in the stack. Another thing is printing the myfunc itself. But as we have mentioned, that the code of the function itself has a code object inside, and that's why this it disassembles the code, the function body itself also. So what we have here is inside the body of the function we use the list comprehension, and that's why it shows that we have used it. Then we use the list itself here, k, and that's why it's shown here also. So we are loading the global variable. As you see, this is a global variable for this my function. If we declare some variable inside the my func or inside the function, it's a local variable. So this is a global scope, and this variable is loading from the global scope. We will dig into each opcodes for sure, but for now, just I'm giving the basic idea what's going on behind the scene. The next thing is that when we disassemble this list comprehension action itself, it's going to build list, and it's going to create a for iterator. It's going to store this I in the stack, then load it and binary multiply. We have multiplying here, as you see. So it's going to binary multiply, then it's going to append this binary multiplied value to the new builded list, and it's going at the end return the value. So this is actually what's going on behind the scene when you run each time your Python code. So if it's hard, don't just afraid about this. We will dig into it. So it's just intro what's going on behind the scenes. So the next video we are going to further improve our knowledge about the operational code evaluation loop, how it's stored and written in the CPython, the source code, and what actually we can learn by exploring this, disassembling our code, and how it can improve our code speed or the code quality. That's it for now. So see you in the next video.